Good day, everyone. My name is David Williams, Executive Director of the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Accelerating Clean Energy at Scales. We're grateful to our moderator and speaker, Douglas Arent and Megan Day from NREL for today's timely discussion. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues among professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations, along with a host of other products and services that you can find at our website at www.iae.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regard to today's webinar before I hand things over to our moderator. First, this webinar is being recorded for those that cannot participate in today's live event. If you have questions for our panelists, please click the Q&A button at the bottom of the Zoom window and type your question. We've allocated sufficient time at the end of this webinar to address your questions. And now I would like to introduce you to our moderator and speaker, Dr. Douglas Arent, Executive Director of Strategic Public-Private Partnerships at the National Renewable Energy Laboratory. Doug, over to you.
Thanks, Dave, very much, and pleasure to be with everyone today. And I'm of course joined by Megan Day, a senior energy planner, and we're gonna split the presentation. I'll turn it over to her in a few minutes. If we could go to the slides, please. I will launch in a little bit on this topic. I think for those familiar with IAEE webinars, many of them dive in deeply to an economic analysis of a specific topic around a policy or technology or suite of technologies, or look at scenarios for futures. And this one will touch on that, but most importantly, I think, let me start with the beginning of what NREL is and where we are and how we fit in the ecosystem. If you go to the next slide, please. NREL at a glance, for those not familiar, began in the 1970s as the Solar Energy Research Institute and is currently the National Renewable Energy Laboratory in the United States. The quick statistics are here up on the slide. It's actually a relatively large national lab operated by the Alliance for Sustainable Energy. It's one of 17 national labs in the United States, and the only one that focuses on renewable energy and energy efficiency, with a mission to innovate in those technology spaces and surrounding ecosystem and accelerate their adoption into the marketplace. We actually operate in about 90 countries around the world with fairly dedicated activities in 40 of them. And so if you do have questions about either other NREL activities or this particular topic and how it fits into the international context, please feel free to post those. So if we go to the next slide, just some context for thinking about NREL and thinking about the clean energy transitions which are happening around the world. Strategically, we think about this in 3 primary areas. The first is in integrated energy pathways. And here one can really think about the integrated energy economy, lots of modeling on this and lots of thinking deeply about how this will transition, in particular, a lot of economics and analysis looking at the transition of clean power systems and clean power as the basis of a clean energy economy. Clearly looking at power to X, what we call in our second pillar, electrons to molecules. And in that first one, it's not only power, but it's also distributed energy resources, advanced computing, artificial intelligence, cybersecurity, et cetera. There are many, many components of that first one, including, of course, electrification of mobility, I'm sorry. And then the third element is really thinking much more deeply beyond just the expansion of clean energy provision, but really about the whole circular economy of the energy economy, and particularly for energy materials. So that kind of wraps up in three big buckets, and happy to answer questions about those as well. But as we think about that in the context of, thank you, Megan, the US energy changing, the energy mix and how it's changing, as well as globally, and this is just one good example. These are quick slides from the Energy Information Agency, their most recent annual energy outlook. And on the upper left, you see kind of three graphs contrasting a reference case that tracks historically from 1990 to 2050 on the amount of electricity generation provided by four primary sources, renewables, natural gas, coal, and nuclear. And then the two right-hand graphs show two other alternative scenarios, one being a low-cost renewables case and the other one being a high renewables cost case. There are, of course, other scenarios as well. I think strikingly, what you can see is that between the reference case and the high-cost renewables, there's only about 500 billion kilowatt hours differences there. But natural gas, and the trade-off is really between renewables growth and natural gas growth. And that clearly plays out if you look at the third scenario on the right, where in the high-cost renewables case, and this is a reference natural gas price case, natural gas continues to move forward at a pretty substantial pace, while coal continues to decline across all three scenarios, and nuclear basically plays out according to license extension. I think the other graph I really want to draw your attention to is on the lower right. And here you see both retiring and new generation capacity. Again, reference case going forward. You can see predominantly that it's natural gas, wind, and solar growing, and essentially no new coal and no new nuclear going forward. What this really tells us is that there is an overall transition at the US national level, but really what is happening at the subnational level driving this transition and how it's actually going to play out. So now let's look at what's really happening underneath the national level. So Megan, if you can pop to the next slide. In the US, we have a very contrasting, shall we call it, institutional structure of how energy is, and particularly power, is planned, operated, regulated, and managed. It's a very federalist system where we have the Federal Energy Regulatory Commission overseeing interstate activities, and then states really having primary jurisdiction over state level boundaries. But within that, there are more than 1,000 quote utilities, many of them being rural co-ops, some of them also being municipalities and independent operating utilities as well. So it's a very strong heterogeneity relative to many other countries, and it also then it gives states and local jurisdictions incredible say in how their energy evolves going forward. So with this in mind, if you can go to the next slide, Megan, we really think about a clean energy transition implementation plan. And here, this is very contrasting to, shall we call it, economics and policy analysis. This is really about peeling the onion from ambitions and policy goals into implementation plans and action plans. And you can see some of the main components, which I will not spend any time on right now because Megan will talk about this in much more detail. But it's really about getting down to the nuts and bolts from the local level all the way up to the national level. And the next slide, Megan, please. One of the key things to recognize is that for many, many years, local jurisdictions, including states, municipalities, and rural co-ops, have driven a significant amount of change in the US energy economy, and businesses have been driving change not only in the US energy economy, but in the global economy. And it's this pursuits of whether or not it's 100% clean, decarbonized. Some are saying 100% renewable. Others are just saying we want an efficient, affordable, reliable, resilient, and sustainable energy economy. All of them are looking for ways to really map out how to achieve that. And so it's the next slide, if you would. It's really about translating these ambitions into actionable plans. And so accelerating clean energy at scale, as we titled this webinar, is really about providing customized, holistic modeling analysis to support the strategy development with communities and partners. What it does is it peels the onion with good engineering, foundational-based economic analysis to offer insights into where does infrastructure need to be built, how much infrastructure needs to be built, and then, of course, what program designs need to be put in place in order to attract both the private as well as the public capital in doing that. And of course, then comes the policy and the tariff structures, et cetera, that go with that. Next slide, Megan, please. NREL itself has had many, many decades of experience of this type of support. And it comes in very, very different flavors. So for example, the state of Hawaii, and I know this from personal experience, was asked to put together a clean energy analysis plan back in 2005, was part of the EPACT Energy Policy Act of 2005, and I helped oversee that report. Really laid out a transitional roadmap for the state of Hawaii, which even at that point was facing incredible import burdens by importing nearly all of their energy sources, as well as incredibly high pricing for that. And that's transitioned through now nearly 15, 17 years of partnership with NREL and the Department of Energy to an ambition and a set of plans for 100% renewable energy, had led to a significant amount of innovation in utility tariff formation, as well as technical standards for inverters and other pieces. That contrasts very much with Navajo Nation or Hurricane Sandy recovery or New Orleans work or much of our work in the state of Alaska, which is about serving rural communities, et cetera. So there's a very broad set of examples, and not every jurisdiction enters the conversation in the same way. In fact, they nearly always enter it in a different perspective. And I think that's what drives the need for customizable, but also holistic energy planning and economic support for them. And the holistic piece is really about understanding the interconnection between mobility, power, economic development, equity, and many, many other aspects. Next slide, please. So here's one example. It's a Department of Energy program called the Energy Transitions Initiative that NREL has been supporting. And again, takes this very, what I now call relatively honed approach to understanding how to work with and working with communities and stakeholders. It begins with the fundamentals, as I mentioned. Every community has a different set of priorities because they have a different situation. And then how do they think about partnerships, and how do partners come in, including the national labs and tools, but also consultancies and other analysts, and then doing deep planning and assessment. And then the goal of the ETI program, Energy Transitions Initiative, is really around resilient energy systems planning, but of course includes many of the other aspects that the community has prioritized, as well as DOE has made suggestions around in terms of sustainability, equity, water affordability, jobs, et cetera. Next slide, please. So the idea here is to work with communities across the country and frankly across the world to convene them into a mindful, very structured dialogue around energy and energy transitions, and then use a suite of increasingly open source tools and data to really peel the onion, to do engineering-based economic analysis, and then empower those communities to really move forward and own the actionable plans going forward. And it's this coalition of examples that really helps, not just for local impact, but regional and frankly, national. And while I've mentioned US examples, I can think of many of them across Europe and certainly across Southeast Asia, even Africa, where the work is, based on mini grids or regional industrial clusters for low carbon energy, et cetera. And so it's not just a US phenomenon we're working forward, but it really is globally. So the next slide, please, Megan. So with all this and with partners, and we hope that IAEA, the academic partners and other partners would embrace the methods, the tools, and the approaches, and join us in helping communities across the country and around the world, really to help them translate their ambitious goals into clean, affordable, equitable, secure, and resilient energy systems. And so with that, I'm going to turn it over to Megan to talk a bit more about the history and some of the examples in detail. Thank you.
Great. Thank you so much, Doug. And thanks for joining us here today. So we'll take a little bit of a deep dive onto a couple of examples here. I'll touch on the philosophy that we go by, which Doug has explained to some extent already, and examples of this place-based community engagement in clean energy planning. And take a look at one of the tools that I think you might be interested in, and move on to LA, which is one of our recent engagements as a deep dive where we've done a fair amount of economic analysis. So here we go. This is how we approach engaging with communities, right? We're looking to expand local empowerment to meet both local and national goals. We are a national lab, and so we always have to keep that in mind. Our philosophy is to really accomplish this through co-development of solutions, right? I don't think it would be very effective to have NREL come in and say, this is our analysis, this is how you should go about things, and that would not stick, right? So we're really looking to engage with communities, understand their needs, their goals, and how can we co-develop solutions together and design and demonstrate and deploy those solutions, and then have this feedback loop into our foundational science, into our research agenda, and center equity more and more. We're looking to integrate equity considerations in our tools and modeling, and how can we have equity-centered technology research and development. And that's what we're trying to get at with this image here of an iceberg, right? Deployment, when you look at how technologies and clean energy is deployed, is really just the tip of the iceberg. We're looking to build that underlying foundational science and demonstration and piloting such that it can support deployment in a place-based, equity-centered way. And that takes a lot of work behind the scenes. So let's dive into some stories here and examples of how we've applied this approach. So here's one in Newtok, Alaska, where there is basically a climate change refugee community, basically. So this is a community that was displaced by climate change. It's a traditionally nomadic community that was settled in an erosion zone by the US government, and now is falling into the ocean as the sea levels rise and sinking into the permafrost as the permafrost defrosts, essentially. And so they were facing flooding with sewage as a result of these changing and shifting soils. And so NREL was a major part of supporting this community in relocating to a location where they had access to higher ground, clean water, rich resources, and allowed the community to continue in a subsistence life. And was a culturally appropriate way, right, to relocate this community as climate refugees. So it was a co-developed sustainable solution, again, That's our approach. And in doing so, we were able to support the community in designing 50% less energy use buildings, less than the regional average, as well as healthy air circulation and ventilation systems to maintain healthy homes. So energy efficient infrastructure as well, and then work with the community to train folks to build these new buildings, both the homes and community structures. So workforce development and implementation as well was a key part of this. Another example that touched on the Navajo Nation. This is a tribal nation within the US. And so there are actually two nations that are heavily affected by coal transition, right? This is the largest coal generating station west of the Mississippi in the US. And Doug showed you these declining deployment of coal in one of those graphs, right? It's just not economic anymore. And there were market factors that led to the closing of this generating station on the Navajo Nation in 2019. And in doing so, some people might see that as cause for celebration. However, there were major economic impacts, right? So the coal generating station was actually providing 80% of the governing operating revenues for the Hopi tribe, which was within that. It was not just the coal generation station, but it was also the mine that served the coal to the generating station, and the train that transferred them. So we're talking about 500 jobs that were lost with the closure of this Navajo generation station. In addition, the market factors are, it's not just the increasing cost relative to other forms of generation, but it's also the goals, right? So one of the owners of the Navajo generation station was LA. And as LA was looking to increasingly clean up their supply, they decided that they were not going to take generation from a coal plant anymore in Arizona. So there's goals, there's local goals influencing this change as well. So NREL was able to work through the Bureau of Reclamation and many other supporting entities to work with both the Hopi tribe and the Navajo Nation to on these transitional glide paths, right? How can we develop wind, solar, local agricultural water production and storage using wind and solar power? How can we apply these technologies to try to fill some of that gap that's left in the absence of this generation station and the jobs and economic support that it provided? And so again, co-developing solutions, how do they want to use their land to support this? And in the absence of the coal generation station, you have a lot of capacity left on high transmission lines that go to LA, obviously, and many other off-takers of that generation station. So how can we take advantage of that and build new energy, clean energy resources to take advantage of that capacity? So working again with the communities and with a focus on community priorities and coal transition and employment opportunities. That's the NGS example. I'm going to throw in a tool here that I think might be of interest to energy economists, and that is, as we're working to increasingly integrate equity into these considerations. I mean, obviously we just saw an example of how local job impacts and economic impacts can be really hard on communities in this clean energy transition. The low-income energy affordability data, or the LEAD tool, is a great tool to understand. Through American Community Survey data, we've analyzed it in such a way that we can understand the energy burden, or the percent of annual income spent on utility bills. And so here we see a state mapping, but we can actually take this down to the census tract level to estimate how much of folks' energy bills are they spending from their annual income. So here we're looking at Detroit in Michigan, and it's just a example down to the census tract level. You're looking at neighborhood levels. And so it's not just taking a look at where is poverty, but it's the intersection of both poverty plus where you have older homes with more inefficient infrastructure in the built environment, as well as where do you have high heating costs and high cooling costs. So Detroit is one area where there's high of both, right? They have hot summers, they have cold winters, and the lake effect, right? A lot of wind coming off of there. So there's actually an example I pulled up here of one census tract where it's 20% on average of the annual income that folks are spending on their utility bill. That's really high. It's generally considered 6% or more is a high energy burden and energy poverty. So that's one tool that you might want to explore as far as the suite of many tools that NREL has to offer when it comes to economics. And here's just an interesting overlay when we're talking about equity. This is the EPA's, the Environmental Protection Agency's EJ Screen tool, where they map out environmental justice issues and impacts across the country, the US. And here we're still looking at Detroit, and this is an overlay of where there are high percentages of people of color. You can also look at where PM 2.5 impacts are greater, and there's often an intersection there. So it's a tool to help target some of the benefits of this clean energy transition programmatically, potentially. So another approach. Back into some examples here. This is Kingston, New York, a community of about 22,000 north of New York City by about 2 hours in the Hudson Valley. And this is where we applied that LEAD tool, right? And we're looking at how can we understand where you can target that energy efficiency intervention, as well as potentially programs and rooftop solar to try to help benefit and alleviate some of that energy burden and the most disadvantaged communities and those most in need. So here they had a goal of 100% clean energy by 2050, clean electricity by 2035, which is a common goal and now is reflected as a federal goal in the US. And we were able to demonstrate to them through the LEAD tool, and that's this little circle with the bar charts here, where that energy burden is the greatest as you kind of slice it and dice it by housing type, by tenure, renter versus owner occupied, and by things like heating fuel type, et cetera. And showing here that, that they actually have a very high percentage, right? 43% of households in this community pay more than 9% of their annual income on utility bills. That's very high as an average, and a very big proportion of their community. They also have some very wealthy people in this community, so there's a huge disparity. And so how, as they transition into clean energy, can they make sure that they're keeping equity front and center in this transition? Because it was a very high priority for them. So equity prioritized transition to clean energy. So helping them to understand this disproportionate burden, we applied some other tools like the REOPT and the BEOPT tools. You want to get really nerdy into the tools, but we were able to do deep energy retrofit modeling of about 14 different condemned houses that they were going to transition into affordable housing. And so really modeling for them what is the most cost-effective way to reduce those energy burdens for these residents that were going to live there moving forward, and found that, as in many communities, heat pumps. This is a cold community in the winter, but there's and so many people are coming around to the application of heat pumps even in these cold climates. But heat pumps were the most both cost-effective, lowest energy burden over time, as well as the highest energy savings HVAC solution here. We also took a look at some resilience and PV plus storage. So we looked at their community center, which also served as an emergency shelter, and looked at how could they optimize PV on the rooftop plus energy storage, both to be economic and to support this facility as an emergency shelter, where they also have charging stations for the city, so they can be that sort of full spectrum solution. And so just another example of how we worked deeply and connected with the community to co-develop some of the solutions so that they could look at goals and implementation plans for an equity-centered clean energy transition. And here we're going to tackle LA 100, which is something we've been working on for the past 3 years to model the utility and cities. They're one and the same. It's a municipal utility in LA. How can they transition equitably to 100% renewable energy, which was their goal, and translate that into action? And so we, again, prioritizing the community, and had a lengthy and very involved engagement with community organizations, and very transparent process to make sure that we are creating and modeling scenarios that reflect community priorities and help them understand their options moving forward in reference, sort of in relation to a reference case. And so we, again, stakeholder engagement to understand those priorities and those scenarios that would be relevant to their transition, and a documented inclusive vision and materials tailored to diverse audiences, a lot of Spanish speakers in this area. So translated all of our presentations, et cetera. So very important to have that community engagement piece. And oh, interesting. I'm sorry, losing my my visual here, but so this is basically should be showing the 4 main scenarios that we looked at, and that was oh, it's sorry, it's animated. I didn't know that. Here we go. Senate Bill 100 was basically our reference case, right? If we only follow what's required by the state, what would that look like under a moderate, a high, and a stress load electrification scenario? And the stress here is we're not looking at much flexibility. We're not matching the demand to the clean energy generation profile, right? So it takes more storage and more other resources to meet that disparate time of generation and demand. Whereas the moderate did look at some more flexibility, and the high is very high electrification of end uses, both transportation and building end uses. Early and no biofuels, this was a scenario developed with the community because this is something that was prioritized. They really did not want in-basin combustion, even with biofuels. This would be renewable biofuels, but it was not a priority for them, and actually wanted to explore options without them. A transmission focus, which looked at a greater expansion of transmission beyond the current interconnection outside of the basin, and then limited new transmission. What if they weren't able to build new transmission because of permitting or local opposition, et cetera? So those were the scenarios we took a look at in different versions, right, of electrification and flexibility. And so we found that reliable 100% renewable energy is achievable in LA. And if coupled with electrification and other sectors, it would provide significant greenhouse gas, air quality, and public health benefits. So we modeled out those in detailed economic and air quality modeling that you might be interested in taking a look at. This is all publicly available with videos and the like. As you saw, we made this very transparent process. And so we found that definitely all communities will share in those benefits, air quality, jobs, et cetera, of this clean energy transition. However, improving participation and outcomes would really require intentionally designed policies and programs, right? To make sure that this is an equitable transition that needs to be intentionally integrated into their next steps and their design of their implementation process. We also found that LA can get started right now with many no regret options, right? So this is primarily wind and solar that they need a lot of, plus storage for these significant emissions reductions by 2030. So that's what the mayor has now set as their clean electricity goal by 2030 is the goal there, or 2035, my apologies, but 80% decarbonized by 2030. And so that's a clear priority for them. And then what's interesting, and as we model, not just in LA, but across the country and the world, as we model these locally implemented clean energy transition scenarios, 80 to 90% of those tend to be very heavily focused uniformly on large-scale solar and wind adoption plus storage. It's that last 10%, right, that is where you need to model out what are the local solutions for reliability and for cost effectiveness to meet that 100%, right? So again, high implementation of wind and solar, and modeling out extremely high demand. So, right, this was the utility we're doing this for. So they want to keep the lights on. That was a major priority for them. And so we modeled hundreds and hundreds of different scenarios as to when the wind is not blowing, when the sun is not shining, when you have a fire up in the mountains and you lose a transmission line, how can you keep the lights on when all of these are unplanned events, right, are coming together at once? And so we did a heavy focus on reliability in extreme scenarios to make sure that that last 10% could be met even under duress. And so this combination of higher energy efficiency, electrification of those end uses, and demand flexibility, matching and shifting loads so that you can make sure your demand is higher when your solar energy is higher is the main goal there. They are associated with increased total costs, but they offer both greater benefits and reduced per unit electricity costs compared to alternative scenarios. So this is a way to get at that equity, right? How do you reduce costs on a per kilowatt hour basis for your customers? So other communities can follow LA's lead in this space, right? As we found, and we find, in our modeling across many communities, start deploying solar, wind, and batteries now to make sure, and this is not just NREL, it's many different modeling and research endeavors, right? High deployment of wind, solar, and batteries now will help you be in a better position to research that longer term solution, right? For that last 10 to 20%. What is the cost effective solution going to be at the time of your goal? Like in 2030, maybe it's offshore wind will be lower cost and can help. Maybe there's some other solutions in NREL analysis of LA, because they were exclusively focused on renewables, we modeled out a lot of green hydrogen, actually not a lot, but green hydrogen to meet that very last sort of, it's really 2% oftentimes of that under duress scenario, transmission losses, no solar resource, wind resources low. How can you provide in-basin generation that's renewable in that situation? So we feel that LA 100 pioneered a new replicable approach that other communities across the country and the world can follow. It's holistic in scope, looking at multiple technologies, multiple solutions, energy efficiency, sustainable transportation, electrified transportation. Very high in detail. We've made good use of our supercomputer for this project, and prioritizes reliability. So this is really utility focused. How do you keep the lights on, as we're showing here, and identifying future research and development directions, right? This is the feedback loop into how do we make sure that our research and development agenda is reflecting the needs of these applied scenarios and communities, and positioning us to address the clean energy transition nationwide and globally and be a resource. So as we've talked about a little bit, LA 100 marks a shift towards centering energy justice in this conversation and in this transition, and prioritizing community objectives, open public meetings, transparent process, documented inclusive vision, and ensuring that results are accessible to all. So you can look up LA and find all of our findings, and maybe dive into some of the economic and jobs development that might be of interest to this community. Now, after we've finished this study, as far as modeling the scenarios to achieve that 100% renewable energy as they dictated, now the real question is, how do you get there equitably? How do you get there without placing a much greater energy burden on the lowest income and most underserved and disadvantaged communities in the city? And so that is going to be our focus moving forward, and looking at how we achieve this and improve equity participation in the design of those solutions and the pathways forward, and meet equity outcomes that are dictated by the community, right? Again, we don't want NREL to come in as people who don't live in LA necessarily, and who are in different circumstances, right? We're focusing and organizing this process around 3 tenets of justice: procedural justice, to make sure that we are listening to the community, they are governing this process, and identifying the prioritized equity outcomes that we will design solutions to achieve. Recognition justice, to recognize and demonstrate through research and analysis the inequitable current and historic situation that has been faced, right? So LADWP, the utility, is very aware that their past and current distribution of access to rooftop solar, electrified transportation, EV subsidies, as well as grid interactive efficient building technologies and smart meters, have been heavily trending towards higher income customers. And so the recognition justice is really diving into that, understanding it, and understanding how we can change that trend. And then the distributional justice is looking at how can we model the pathways towards the energy transition in ways that can distribute the benefits of clean energy in a more equitable way to relieve those energy burdens and center equity and clean energy and those disadvantaged communities moving forward. So that's going to be our study focus for the next 2 years for LA, and it's a priority for many cities that we're working with and local jurisdictions in this place-based solutions development. So thank you so much for your time and attention. I look forward to the questions, and Doug and I are going to try to read your questions in the Q&A function here. And so I will exit out of the slides so that we can see those better, and look forward to your questions and some discussion here. Thanks so much.
Yeah, thanks, Megan. This is Doug again for everyone. Thanks for folks. I actually don't see any questions in the Q&A function unless IT is not doing us a favor. So let me offer maybe a comment or two, and if we are close early, then we'll do that. Megan, in experience that you've had working with jurisdictions around the country, or frankly with colleagues around the world, data seems to always come up as a question. The availability of it, the validity of it, filling in data gaps. Can you talk to us about how you and teams have approached data, depending upon the level of analysis that is desired? Very different examples, I think, for Kingston, Navajo, LA, and I think explaining the range of data and analytics that are applied, I think, could be helpful here.
Sure. Well, that's been my focus for about 6 years here at NREL. I'm an urban regional planner. My job is to translate and apply and develop data at jurisdictionally resolved scales, right? So, so the goal that I've been working on is again, taking outputs from our flagship models and tools, resolving them at jurisdictional levels, and then delivering that data on energy efficiency, renewables, and sustainable transportation. Now, that's more important to communities who have less resources and capacity to develop that data on their own. So a city like LA, we are working with mountains of data that they provide to us. That we're working with the utility, they're sharing data such that we can model many different scenarios and deeply sort of dive into that. Whereas there are many communities who don't have a municipal utility, don't have a large government, or as in the Hopi tribe, have just lost 80% of their governmental revenues. They don't have the capacity to generate or analyze their own data. And so that's been a big focus at NREL, is to try to generate and model some of that data for them, to help them take that sort of change step, right, into actions and decision making that can be data-based and data driven, except they don't have to take that time, to develop and access the data on their own, because many communities don't have that capacity, right? There are over 24,000 different local jurisdictions in the US, and many of them are about 2,400 or 2,500 population or smaller, right? The majority of them are actually. So we're really looking to make data accessible to all local jurisdictions and to support these place-based analyses and solutions. So that's been a big focus of mine. One of the tools that I didn't show is the state and local planning for energy platform, where we're resolving again this data on efficiency, renewables, and sustainable transportation at these jurisdictional levels. And we're actually building out a scenario planner, and this might be of interest to economists here, to look at, okay, moving forward through 2050, how might your local scenario, as far as your transportation energy, your electricity consumption and generation, and your natural gas and other fuels, how might that change under a high electrification scenario, a reference in comparison to a reference case? And also, how might that change if you really focus on efficiency, and what are the outputs as far as costs, greenhouse gas emissions, etc. So a strong focus on data here at NREL, so that we can support data-driven decisions.
Thank you. Appreciate that. I think just to maybe double click on the LA example for folks, particularly for PhD researchers who are listening to this, is that one can think about, I'll just take an example of electric demand, and then how to meet electric demand by supply. And that's a classic energy economics problem. And the real question is at what spatial and at what temporal scale do you work at? There are many planning tools which aggregate things into annual demand, and/or one could break that down into monthly demands. LA, for example, did 5-minute demand profiles, including building demand, electric vehicle charging, all at spatial resolution that was able to break it down into essentially a sub-zip code spatial resolution and individual building blocks. And so that's why Megan had suggested the use of our supercomputer and quote mountains of data. That was about 5 terabytes of data, if I remember correctly, for the LA project. That's very different than running a spreadsheet on a simple computer. And so we just need to be mindful of the fact that when I talk about engineering oriented energy economics models, it really is down in to where from the power system side, you can actually include the engineering criteria for reliability, security, resilience, et cetera, as well as then look at all the economics. So we have about 7 or 8 minutes left. We'll give you a couple minutes before the top of the hour. There are 3 questions in there. The first one I'll answer very quickly. If you're interested in working at NREL, please come to nrel.gov and go to our website. If you know a researcher, feel free to reach out directly. We're always looking for top talent from around the world to come join us. So second question in here, and Megan, maybe you can take this one, which is, in your view, how do you think circular economy or the circular economy transition could be promoted within community energy planning initiatives? It really hasn't been, I think, part of our previous examples, but I think going forward, would love to hear your thoughts of how do communities think about kind of circularity per se.
Yeah, it was interesting in our extensive community engagement with the community of LA that one of the top prioritized outcomes that they wanted to see was the circular economy. That's what we would name it, right? They were looking at, okay, I think it was primarily focused on batteries. They're like, yeah, storage is a major solution here, it seems, and we don't want waste from batteries to be a problem as a result or an output of this decisions that are made. So how can we make sure that there is recycling and the sustainability of the materials and the technologies that we are applying here in this transition. And so it's definitely a community prioritized outcome that they wanted to see. At NREL, we are looking at some amazing technologies to look at wind turbines, right? That's a lot of material, and they're repowered at a more frequent schedule than say solar panels, which is more of a 25, 35 year sort of lifetime. We might be looking at repowering more often for wind turbines. So how can we make those materials actually reusable, recyclable, such that we aren't just filling up landfills, which is an increasing concern of local communities, right? They have only so much landfill capacity. They don't want one project to fill it up and then they're done. So it's a priority at the local level for sure. And we're also working on at NREL on some plastics recycling and these sort of decomposition strategies and technologies and microbes. It's really fascinating work at NREL and that circular transition as far as plastics and other technologies. So batteries will be a big one that we'll need to focus on moving forward in that space as well.
Great. Two more questions. One, I think particularly for you, Megan, in Alaska and or with the Navajo Nation, given the fact that many jobs are focused around fossil fuel production, either coal, as you mentioned, for the Navajo Nation, or perhaps, and I'm not sure about this, in Alaska, whether or not really Alaskan jobs of the natives are tied to oil and gas production. I believe, I'm not sure about the data behind that. What views and what perspectives came into the conversations about the economic transition and jobs? Maybe you could focus on the Navajo Nation piece, and if you know about Alaska, great to comment on that as well.
Yeah, it's a tough situation, right? Most folks want clean energy, but they also want jobs, right? That we can't prioritize one without thinking about the other. And as far as the Navajo Nation went, they were really focused on trying to keep the Navajo Generation Station operating, to save those jobs, to save their economy. And unfortunately, it really took away from their ability to focus on what was the coming transition. And so part of that was our role to show them the economics of coal in that hub as an example, and how uncompetitive it was. And the writing was on the wall. This plant was going to close, even if, you know, folks wanted to keep it open. The economics just weren't there to support that. So how can we look at that glide path? Because it's coming. It's just a matter of when. And it ended up being sooner rather than later for Navajo Generation Station. So yeah, that can often be a priority, right? We're working with tribes in Oklahoma where there's a lot of natural gas and oil extraction. And so it can be a big part of the local economy and job development. And so creating those glide paths, helping tribes and communities understand the economics, such that just because the jobs are there doesn't mean that the economics are going to support this on sort of a regional market scale, such that they can be thinking about some of these transitions. In Alaska, the same thing goes, but in Alaska, there is a lot of reliance on remote and islanded communities on diesel fuel for power generation, which is hugely expensive. So there's I would say perhaps more of an impact on sort of the cost of fossil fuels in their economics than there is on reliance on oil and gas extraction for some of the remote and tribal communities. So helping them get off of reliance on diesel, which has to be flown in. So not only is diesel expensive, you have to fly it in, which makes a very expensive proposition to power your community on diesel in that way. So transitioning to clean energy and more efficiency is a major economic driver that can support those communities.
Great, thanks. Two other quick questions, and I think we'll probably have to cut it off at that point in time. So Michael asked a really good question in terms of how do the pathways differ based upon utility or industry or market structure? And I call it, this is the pathway toward low carbon. So whether or not that's what the goal is, and are there generalized lessons? And I'll start here, and Megan, please feel free to chime in. So Michael, I think, what we are hearing across the different jurisdictions, and that be it a co-op, a muni, an IOU utility, and or a regulated utility, is that they have to, one, take into account the multiple perspectives of their stakeholders. So that doesn't really change, although the orientation of how they do that changes, because the regulated utility, of course, has a pretty defined pathway in terms of how they go about submitting IRPs or whatever other plans to their regulators, et cetera. But there is a standard public process even in that world. I would say the biggest difference from our breadth of experience, or at least in my filter of that, is that folks have different timeframes. They are driven by different suites or different portfolios of priorities. So in LA, for example, the mayor, through a stakeholder process, was very ambitious around 100% renewable energy goal. And LA owns and operates its own utility. They own their assets. They do buy and trade power within California and the West. That's very different than Xcel Energy or Duke Energy from a utility perspective, who are looking to a decarbonized energy system, with the principal focus being on least cost and high reliability, because they know that they have to put plans in place and get them approved by a regulator. It's very different than LA, which is the stakeholder driven process where they may accept more expensive options because they're a community that's willing to accept that and invest in it. Those are a couple of contrasting elements that I could see. I would say the fundamental, I'll call it lessons learned or generalized lessons, is the appreciation for very in-depth analytics and an independent non-advocacy analysis that actually does incorporate sufficient engineering physics or power system physics in it, particularly for the power companies. And and LA Department of Water and Power is a power company. So that's a generalization that I would say goes across. And I would say also that people increasingly are appreciating the fact that we can do spatially and temporally resolved analysis and give them much more insight in terms of kind of what is the scale of infrastructure development. I know we're just about out of time, so Megan, I apologize. I'm going to not offer you an option there. And Jamil, you offered a very quick question at the end. How is electricity storage influence the cost dynamics of renewable energy? I'm going to suggest, and maybe I'll put in the chat, a link to NREL's publication website, and just put in renewable energy and storage. There are probably 50 publications in there that dive into that in quite some detail. So at that, we're just about the top of the hour. I will turn it back to our host at IAEA to close us out. Thank you all very much.
IAEE wishes to thank Doug Arent and Megan Day for an outstanding webinar. This webinar will be available on IAEE's website for future downloads. If you're not a member of IAEE, we encourage you to join by visiting www.iaee.org. We thank you for attending, and I officially close this webinar.